I'm positive you have signed up to a service or created any account, and this video is all about how you can achieve the infrastructure of such applications using Aspnet Core. That's because it's a step-by-step on how to create your first REST API application with MongoDB and Aspnet Core, everything with Docker Compose in the infrastructure. So stay tuned if you're interested. So the first thing we want to do is to create a .NET API application. And using the .NET and the command new, you can easily find any available template on your computer. By looking a little bit, we can see that there is this Aspnet Core Web API template, which is short for Web API, and that's the one we're using. So with .NET New, the template short name, and we can add some flags like dash, and for name, we go with LuPy with capital L because of the Microsoft's name convention. And the first thing you see is the program created. So we see the LuPy folder, and you can cd into this folder and .NET run to start the application. That is going to read all the middleware pipelines first and then execute the program and expose it on the port, in this case 5172 in your local host. So you can easily navigate to this local host, and one of the nicest things here is that the Swagger is available for you to see the documentation right out of the box. And that's where we start, but we're gonna dig deeper into it later. For now, we're gonna see some Docker and how we can use Docker Compose to make our local infrastructure. So if in the case of your computer Docker is not installed, you have to go ahead and install Docker. The easiest way for Windows is by downloading the Docker desktop. We can easily navigate to the browser and Docker desktop for Windows and go in the highest scored option and download the one for your operational system. Well, now that you followed all the steps to install Docker Desktop, we can go ahead and use Docker. But what's pretty interesting about Docker Desktop is that it not only installs the Docker CLI, but also installs the Docker Compose CLI, which enables us to write a script in docker-compose.yaml file, any .yaml file that you point, to automate an entire local infrastructure for your project dependencies, such as a local database. And that's what we're going to figure out together. So let's do it. So the first thing we want to do is to look for some Docker Compose YAML file for a MongoDB. I have previously made this search, so I know the simplest one is this one here, and that's good enough for us to start figuring out how to put it all together. So once you have the file, you can easily Docker Compose -t to detach the initiation of the containers to your terminal and let it run in the background of your computer, but also having a MongoDB in the latest version with root as the username and root password as the password for you through the 27017 port to access your MongoDB database. All the dependencies are being downloaded, and you can wait a little bit for it to run. So you're going to be able to access your database. We allow access and it's there. We can see that we already have a MongoDB instancing being up through our Docker Compose file. If we have any other local dependency for our project, we can use Docker Compose to add it here and not worried about having different versions or problems with local infrastructure anymore. But now we want to connect to this database, and there is a pretty interesting way for you to interact with a local database, which is the Compass. So this GUI can be downloaded here in the internet. So we can download it for the operational system we have, and it's not that complicated. So here we have the Compass and we can download it and execute it. So for MongoDB, even when it's localhost, you should use this format. You can follow this to make your connection with the parameters you passed within your container creation. So localhost host. And then we expect this to connect to the database. And there we go, we are connected. So now we can create data through this database, and that's when we start making the connection through Aspnet Core. To create this MongoDB connection, the first thing we want to do is to add the driver to the local CS proj. We can do this by adding a new package to the project and write the proper name. Now that we have the driver already installed as a project dependency, we can use the standard practice to get the configuration information. One standard practice though is to use one of the following files, the appsettings.json or the appsettingsdevelopment.json. We're gonna stick with the appsettings.json file to add the configuration for the LUPI database, which is the one we're going to create in order to accrue data. So we're gonna stick with the naming convention of Microsoft, and here we can add the connection string itself, which we are going to use to connect to the database, and we can also add the database name, which is going to be our LUPI database, and we can add the collection we're going to work with. This is going to be users. So once we are going to use the users database, we can get rid of the model and get rid of the current controller here. So we can create the user model here into models folder. This user model is nothing but a user class that is going to have its name, username, and the age. We should start the object by now with this signature. So those two parameters are alright, but MongoDB holds an interesting pattern that enables us to differentiate ID so we do not alter it. And we also add the bson ID. We can use the bson element as well to pass in some parameters. They're going to be different on the database, but you want to treat them in a typed manner with their proper name or a different one. That's up to you. So there we are with a great representation of a bson object, which is enough to data transfer all the information we want about the user, in this case username and age. Also, we have to add a model for the configuration. So we're going to add all the parameters we add. So I hold Alt for that, and is the process for me with Shift Out and Control Shift Out and Control V. So it makes things a little faster in this case. And that's alright. We can pretty much use it that way. So now we want to add the loading of this configuration here in one of our pipelines, especially the one responsible for loading the database. So we should go user database configuration. That's an interesting way to have even the configuration in a typed manner. So we can call the setting by its name, and the name is here, loop by database. There we go. So we should just remember that any part of our code should be inside a namespace related to the name of the folder it is in, so it eases the process of locating and retrieving parts of our code. By namespacing the parts of the code, we can know exactly what to retrieve, and now we're all set. So we can go ahead and start a service that is responsible for retrieving user data. This service is, as we know, within the services namespace, and it's just the class responsible for retrieving the information for MongoDB users collection. So we're gonna have a read-only variable responsible for this, because what we want is a collection based on user. Of course, we are getting this from the user driver, from the MongoDB driver, and of course it is from our models, hence the importance of the namespace. And we can construct this service using AI options based on the user database configuration we set there. And now we can create our Mongo client. Receiving all the user configuration settings. So we're going to get the loop by database using the Mongo client to get the database, and from one of the values we're going to use the database name. So now that we have the database loopy, we're going to instantiate a collection from this database that is going to be typed as the model we created previously, also with the name we set in the configuration. So following the convention, we can use the name getAsync when we're going to resolve the thread within the function. So if we're placing this await, that's because we're going to get it asynchronously, so the thread will wait till we get the value. So we should get all the values, and to retrieve all of them we can simply assert the question to true. So to list async, to add the values, and then we have a retrieve of all the values. Later we could use this retrieve in a paginated manner, but for now we're gonna keep it simple. Also, to make a creation of a user, you just need to set it like that and insert a user. What's interesting about MongoDB is that anytime you insert the user, the table gets created, so we do not have to worry much about creating the database structure previously, which is pretty interesting as well. So we could also create a simple replace async verb. So we have the ability to replace an entire object if needed. We do have ways to replace partially an object, but that's for another video. Here we can link ask if the ID is the same as past, and the database will take care of changing it for you, and you can pass in now the new user, which is a hard replacement for the previous one. So you should be careful with such functions. Also, we should be careful with the later one, that is the possibility to delete a user, because once you delete some data you can never retrieve it back, so be sure it's not sensible. Now that we are almost all set, we should create the user's controller. And remember that it's in the namespace of loopy controllers. AI dash controller, and it's gonna take care of using the name of the class. Now we write the class, extending the controller base from the MVC of Aspnet Core, and the only dependency that we care about here is the service, which from where we just created, and we let it be constructed in the controller. This way we inject the dependency on the initiation of the application through Aspnet Core containers. We can simply add it and construct one with the parameter. Now we can freely insert some data into the database. As it's a REST API, the response is always a action result. Now we can add the container of our service within the services before building the application. So we add a singleton in this case, because that's the life cycle of the service. It's a stateless one, by the way. Users service. So because we passed that, the Aspnet Core will take care of instantiating all the dependencies we added to this. Now that we created the controller, we can clear the terminal, and we should just .NET run it, and the application will open in the terminal the same way it did before, but now it's gonna have the new route we just added. And through this route we can first try it by removing this ID. We're gonna do this removal later, and we create the user Daniel of 23 years old. So after the execution, we expect the compex to reflect this data. For this, we refresh the database, and there we go. For now, as you could see, we have the local environment completely platform agnostic using Docker Compose, and it can be as extendable as we want to. But in the next episode, we're going to not only have it for the environment level, but also to the build of the application level, so it could run literally anywhere. So stay tuned and see you in the next episode.